Hi everyone. Today we're going to talk about end behavior. So hopefully you remember end behavior from last year, but if not, let's talk about it. So end behavior is how a function behaves as x gets very big or very small. And by small, I don't mean like tiny, 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 tiny. I mean very, very, very negative. So as far as we can go to the left, as far as we can go to the right. Okay, so here's our notation. So this is called limit notation. So if you ever see somewhere like, oh, I'm supposed to write it in limit notation, that sounds scary. It isn't. It's the limit of whatever your function is named as x approaches negative infinity. And that's because over here on this side, that's where x approaches negative infinity. X approaches positive infinity over to the right. So that's why that's the right side. So each of these, you're going to have to do something to put the limit of f of x as x approaches negative infinity is something. And that's what you have to fill in. So those blanks will be filled in with either infinity, negative infinity, or sometimes a number. So let's look at the end behavior of these. So use the end behavior using limit notation. So first let's look at the left side. So the left side is where x is approaching negative infinity. And we'll just call him f of x, that's fine. Now over on this left side, we can see that my graph right here is going up and up and up and up, right? So that means that my function is approaching infinity. So I'm going to put an infinity right here. Now let's look at the right side. Remember, the right side is where x is approaching positive infinity. Kind of silly looking infinity, but you know what I'm trying to say. All right, down here, see how my arrow is pointing down? That means that my function, as x gets really, really big, goes to negative infinity. So I should have a negative infinity over on the other side. So those are the situations when you'll have a positive infinity or a negative infinity. Sometimes there ends up being a number there instead. So if it approaches a specific number, you're going to have these. Those lines are called asymptotes. So if you have an asymptote, you're probably going to have something silly for your end behavior. So let's first look at the left side. The left side is where x is approaching negative infinity. And maybe this graph's name is g of x. So over here, as we are getting smaller and smaller and smaller, we're seeing that we're going in the same direction as that red arrow, right? The graph is getting closer and closer and closer and closer to that line. Well, that line right there is y equals 1. So since my graph is getting closer and closer to y equals 1, that means that it's approaching 1. Now let's look at the right side. So on the right side, x is approaching positive infinity, and we named him g of x. Over here, it's the same situation. My graph is coming up and getting closer and closer and closer to that y equals 1. So since I get closer and closer and closer to y equals 1, that is my end behavior. That's what it's getting closer to, 1. Go ahead and try the next two on your own. Down here, my graph goes down on both sides. So on both the left and the right side limit, my function will be approaching negative infinity. And over here, over on B, even though they didn't actually graph out our asymptotes, we have an asymptote right there at y equals 0, and we can see how our graph is approaching 0 on both the left and the right. So that's what our end behavior is equal to. All right, see you guys later.